Section 3.2 Quadratic Functions. Learning objectives. In this section, you will recognize characteristics of parabola, the shape, vertex, axis of symmetry, zeros, and the y-intercept. Determine the quadratic function's maximum and minimum value, and also solve problems involving quadratic function and its maximum and minimum values. So quadratic functions. And our parent function for this is, if you remember, f of x is equal to x squared. What are the characteristics of a quadratic function? All quadratic functions have a general U shape, and we call it as, we call it a parabola. And the vertex is the top or the bottom part of the graph. It is a turning point of the graph where it changes from increase to decrease. So let's say you have this as a U shape, as a parabola, and this is the vertex, the bottom part of the graph, and it is a turning point where it changes from this U shape, decrease to increase. The other one, this is the top part, and it changes as increase to decrease. So that these are parabolas. If the graph is ball up, smiling, then the point is the minimum. So this point here is the minimum, and if the graph is ball down or frowning like this, then this point is the maximum. Yes. And at the vertex runs a line of, symmetry. We call the x-intercept the roots or the zeros of the function. Okay, the x-intercept, the points on the x-axis, we call them as the roots or the zeros of the function. And take note of this, all quadratic functions have the domain of, all real numbers or from negative infinity to positive infinity. Okay, so example number 1, determine the vertex, the axis of symmetry, the zeros, and the y-intercept of the parabola shown above. So this is a parabola that opens upward, or it is smiling, right? Okay, so this is the vertex, which is the lowest point, the bottom part of the parabola. So we write it as the vertex. And what are the coordinates of this? That's 1, -4. Then axis of symmetry is this dotted line here, and that value that is at x is equal to 1. What else? The y-intercept is this, the point on the y-axis, which is 0, -3. And the zeros. What are the zeros? The points on the x-axis, or we call them as the x-intercepts or the roots. We have 2 points on the y-axis that is on the parabola, that is on the graph. The first one is when x is -1, and the other one is when x is equal to, yes, 3. Okay, so that is the vertex, the axis of symmetry, y-intercept, and the zeros. Next example, number 2, determine the vertex, axis of symmetry, zeros, and y-intercept of the given parabola here. So vertex is, since this is smiling, again, you have the bottom part of this parabola, and that is the vertex. What is this? 3, 1. Axis of symmetry is this. That is x is equal to 3. Or the best way to get the axis of symmetry is the x part of your vertex. So x equals 3. And zeros, as you can see, I don't see any point that is on the x-axis, so none. And y-intercept, is there a point on the y-axis? Yes, this point, and that is at 0, 7. Very good. Next is the general form of a quadratic function. We will express quadratic function using what's called as the general form. And the general form of a quadratic function looks like ax squared plus bx plus c, where a, b, and c are all real numbers. If a is greater than 0, then the parabola opens up. It's smiling, and the vertex is the minimum or the bottom part of the graph. If a is less than 0, the parabola opens down, it's frowning, and the vertex is the maximum. So this is like parabola that opens downward, this is up. Okay, that is when a greater than 0, a less than 0. And also, if it's greater than 0, definitely, we know that it's positive. Less than 0, that is a negative a. And the axis of symmetry is defined by x equals, the easiest way to get the axis of symmetry is negative b over 2a. Please remember this. From the general form, you have a, b, and b. So axis of symmetry is negative b over 2a. And the zeros occur when, yes, that is when f of x is equal to 0. And to solve, we can either factor or use the quadratic formula. I hope factor or quadratic formula. Do you remember quadratic formula? Okay, let's try an example here. Example 3. Write an equation of the quadratic function below as a transformation of the toolkit function f of x is equal to x squared. Expand the formula and simplify terms to write the equation in general form. So, from the last chapter, you learned like parabola is, you have the stretch factor. H is to the left, to the right. K is like up and down. These are the transformations. Here, how do we write an equation of this parabola? So this is y equals, we don't know what an a is for this. From the origin, think about your parabola here. You move this is the vertex of parabola, you move this 2 to the left and down 3. Do you agree? So if you move it 2 to the left, that's going to be x plus 2 squared, down 3, so minus 3. Okay, so that is the way to write this equation. Now, how do we get our a, which is the stretch factor? The easiest way to get an a is you can get any point that is on the graph, like this one. This point is 0, -1. So this is your x, y. You can plug in x, y here to solve for a. So I'm going to do that on top here. So y is -1 equals a times x is 0 plus 2 squared minus 3. And then if I add 3 both sides, it's going to be 2 equals a. 0 plus 2 is 2 squared is 4. And then divide both sides by 4. So a is 2/4 or 1/2. So we could use that as 1/2 times x plus 2 squared. If we expand, x plus 2 squared is, yes, x squared plus 4x plus 4 minus 3. And then distribute 1/2. 1/2 times x squared is 1/2 x squared plus half of 4 is 2x. Half of 4 again is 2 minus 3. And this is going to be equal to 1/2 x squared plus 2x. 2 minus 3 is -1. So this is the answer in general form. Okay. Next, finding the maximum and minimum values of quadratic function. Remember that the vertex tells us where a quadratic function has its max or minimum depending on the sign of the leading coefficient a. So example number 4, find the minimum value of the quadratic function f of x is equal to 2x squared minus 6x plus 7. And why is it a minimum? So our a here is equal to 2, b is -6, and c is 7. And remember, from above, the axis of symmetry is x is equal to -b over 2a, and the axis of symmetry is the x part of the vertex. So that's why we can solve now for x of the vertex. So let's do that. We have a, 2, and b is -6. So negative b is of -6 over 2 times 2. Negative is positive. 6 over 4, 2 times 2. So that is 3/2. And then, so we have x as 3/2. Then we want the y. How do we get the y? So to get the y, yes, we just have to substitute the value of x to our f of x. So it's like we need to solve for f of 3 halves. So 2 times 3 halves squared minus 6 times 3 halves plus 7. Yes. 3 halves squared is 9/4 times 2 is alright, I'll show it to you. When you square this is 9/4 minus 6 times 3 is 18 halves plus 7. 2/4 is 1/2, so this is 9 halves. 18 over 2 is 9 plus 7. Negative 9 plus 7 is 9 halves minus 2. And 9 halves minus 2. 2 times 2 is 4. 9 minus 4 is 5 halves. Are we done? Yes, this is actually what we want to find. The 5 halves, the y, is the minimum value. Okay, the minimum value here is the output, which is the y. So this is the y part. Okay. Next, applications of quadratic functions and the vertex. Any problem that has a square power can be modeled with a quadratic function. Especially useful is the fact that gravity makes a projectile follow a parabolic path. Example number 5, Steph Curry, who is a 2-time MVP, shoots and makes a 3-pointer using a horizontal velocity of 21.5 feet per second. The basketball's height above the ground can be modeled by the quadratic function h of t equals negative 16 t squared plus 25t plus 9. The questions: when does a basketball reach its maximum height? What is the maximum height on the basketball? When does a ball go through the hoop, which is 10 feet tall? When does the ball hit the ground? And letter D, are the Warriors going to be championship again soon? So we can say here, we're talking about the height. So that's the h part. And h is in feet. And the t is the time. That is in seconds. So letter A. When does a basketball reach its maximum? So meaning we need to get the vertex. And to get the vertex, to get the x part of the vertex, which is t, is equal to negative b over 2a. Remember, what is negative b here? B is, a is negative 16, b is 21.5. So this is negative 21.5 over 2 times a is, yes, negative 16. So negative over negative is positive. So 21.5 over 32 is approximately equal to 0.672 second. And then we need to get h of t, h of 0.672 from the given. So that is negative 16 times 0.672 squared plus 21.5 times 0.672 plus 9. and this is actually equal to 16.222 feet. So actually, with this vertex, the t part is the 0.672 second. That is, when does the basketball reach its maximum height? So that's the answer for letter A, 0.672 second. And letter B, what is the maximum height of the ball? That is the h of t, which is 16.222 feet. So this is the max height. Okay, so this is also your letter B. Now to answer letter C, when does the ball go through the hoop, which is 10 feet tall, and when does the ball hit the ground? So what do we mean by goes through the hoop? That is, h of t is equal to 10. So we have here 16t squared, negative 16t squared, plus 21.5t plus 9 is equal to 10. And then we can solve for t. If we subtract 10, this is negative 16t squared plus 21.5t minus 1 equals 0. And if you use a calculator here, you'll be able to find that t is equal to 1.2955 seconds. Are the Warriors gonna win the championship again? So by the way, here, this is the vertex, which is the maximum height. And this part here is the 10 feet. And we'll see if they're gonna win the championship again this year. Okay. Alright, so next we have the next 3 problems here for lecture questions. For the following exercises, determine whether there is a minimum or maximum value to each quadratic function. Find the value and the axis of symmetry. So 14, y of x equal to 2x squared plus 10x plus 2. Find the value and the axis of symmetry. So what do we do here? So we can use that, since it's in the general form, a is 2, b is equal to 10, x is equal to negative b over 2a, so that is negative 10 over 2 times 2, and this is negative 10 over 4, and that's equal to negative 5 halves. So this negative 5 halves here is actually your axis of symmetry. And how do you find if it has a minimum or the maximum value? A is 2 and A is greater than 0, so meaning it has a minimum value. It's positive. If A is positive, so then it has a minimum value. And what is that value? So since after you solve for x, we can solve for y. So y of negative 5 halves is equal to 2 times negative 5 halves squared plus 10 times 5 halves plus 12. 2 times 25 over 4 plus 50 over 2 is 25 plus 12, and this is 1/2. 25 plus 12 is 37. Oh wait, sorry, this negative 5 halves, my bad. This negative 25, negative 25 plus 12 is negative 13. Yeah, and to simplify this, 2 times negative 13 is negative 26. 25 minus 26 is negative 1/2. So this is the minimum value. So you have this x, which is the axis of symmetry and the minimum value. So meaning the vertex, if you want, for number 14 is at negative 5 halves and negative 1/2. If you want to get the vertex. Okay, so remember, this is the axis of symmetry, the x part of the vertex, and this is the minimum value. Okay, I'll let you work on 18. I'm pretty sure you can do this. Just a hint here, A is negative 4, and that is negative less than 0, so meaning you should have a maximum value. So you can, A is negative 4, B is 6. You can use negative b over 2a to solve for your axis of symmetry, and then plug in that to the t for you to get the maximum value. Okay, so please try that. And the last problem, write the equation of the graph function in general form. You can start with using the transformations of the toolkit function f of x equal to x squared. So again, remember y is equal to a times x minus h squared plus k. A is a stretch factor, h to the left, to the right, k is up, down. So think about the toolkit function f of x equal to x squared. So remember, a parabola that opens upward. That is the f of x equal to x squared. So the best way to do this is when you are starting from the vertex, which is from the origin of your x squared, to the vertex of this given graph. So h is when you go to the left, or to, how do you go from this point to this point? So you move from this point 2 to the right, so that is h is equal to 2 for this, and then you go up 1 2 3 4 5 6 7, you go up 7, so that is your k is equal to 7. So let's write that. So y equals a x minus your h is 2 squared, you go up 7, so that's your k, so plus 7. And then now, how do we get a value of a? So we can use any point that is on the graph. The easiest is if you have a point on the y-axis. Let's use that 0, -1. So this is x, y. We plug in that here. So y is -1, x is 0, -2 squared plus 7, and simplify. -2 squared is 4 plus 7, subtract 7, that is -8 equals 4a, and then divide by 4, that is -2. And then now we can write our equation. Y equals, your a is -2, x minus your h is 2 squared plus 7. So this is the equation of this graph. Okay. And that's it for section 3.2. Thank you.